Hope you are doing great. Okay, today let us talk about one of the most important topics in mathematics. This is standard form. Um, this is one of the most important topics because some other topics depends on it. And sometimes after asking you questions on some topics, they'll still tell you leave your answer in standard form. All right. So that tells you how important this is. And also this will introduce us to exponents and indices. So without wasting our time, I want to check. Okay, without wasting our time, what do you think standard forms in standard form? Sorry, I'm trying to do something here. A number is said to be in standard form if that number is written in this way: a times 10 to the power of n. Okay, a times 10 to the power of n, whereby your a, 1 has to be less than or equal to a, and a must be less than 10. That is the range. Okay, I'm trying to use this to see what I'm doing and to be sure my audio is okay. So if you are just joining, you are welcome. Okay, okay, the audio is okay. Now, as I was saying, for you to say that a number is in standard form, it has to be in this way: a times 10 to the power of n, whereby 1 is less than or equal to a, which is less than 10. And your n is what? Is an integer. Your n is an integer, right? All right. Now, that simply means that, that simply means that if, let me get a note I need for this. All right. So, any whole number, okay, any whole number has its decimal point at the end of that number. So if you're just joining us, you are welcome. I'll just do a brief introduction again because no one was here before. I said that if you say that a number is in standard form, it simply means that that number is written in this form: a times 10 to the power of n. Okay, and your a, 1 must be less than or equal to a, which must be less than 10, and your n must be an integer. You know what an integer means, right? All the numbers you can see on your number line, positive and negative whole numbers. That is what your n should be. All right. Now, having said that, okay, remember that any whole number has its decimal point at the end of it. For example, if I want to write 2, 2 is same thing as 2.0. Okay. The same thing, if I write 3, 3 is same thing as 3.0. So the decimal point of any whole number is at the end of the number. Now, why is this necessary? This is very necessary because when you are asked to put a number in standard form, always remember that if that number is a whole number, even though the decimal point may not be shown, just know that your decimal point is at the end of the number. And if it is a decimal, the decimal point will be shown. You will see that. Now, I'm going to give you the easiest way of finding or putting a number in standard form. Very easy way. The first is this. Let us note that anytime we want to change a number in standard form and we move our decimal point to the left, then our n will be what? Positive. If we move our decimal point to the right, then our n will be negative. Ideally, in an ideal concept, let me put it that way. When you move something to the left, you expect your answer to be negative, right? But in terms of standard, I want you to always view it the opposite way. Okay? All right. Now, let's start with an example. Let's start with an example. Now, we are going to list what our A could be. Our A, from what we are seeing here, we are told that A is between 1 and 10, but not equal to 10, but it can be equal to 1, as from what we are seeing here. So it means A could be 1, could be 2, 3 to 9. That is what your A can be. Your A cannot be more than 9. All right? Your A cannot be more than 9. That is just it. Okay, now let's start with an example. The first example says, change this to standard form. Change this to standard form. Number 1. The first one says 540. Okay, sorry. Let's start with this. 750. 750. Now, this topic is underrated in maths, but as a teacher, I can stand and tell you that most students don't know this. That is because they neglect it, but it hooks them most times. Because if after answering a question and you are asked to put that answer in standard form and you failed it there, you have lost some mark. So let us start from here. All right. If you're just joining, you are welcome. Give us a thumbs up if you love what we are doing. Now, this is 750, and we need to put this 750 in this form, A times 10 to the power of n. So it means that our A can be 1, 2, 3, 4, 5 to 9, but it cannot be 10. Remember that any whole number has its decimal point at the end. Remember I said that in the beginning of this video. So if I write 750, okay, this is the end. This is where our decimal point is. It simply means that I need to shift this decimal point to get my A. A times 10 to the power of n, and my A must be less than 10. So if I shift the decimal point to this place, I still have 75.0. And you can see that 75 is more than 9, or let me say 10. It cannot qualify for our A according to this range. So we need to shift this decimal point again. So if we do that, you can see that we now have 7.5. So 7.5, yes, it can serve as our A because 7.5 is between this range. It is from 1 to 10, but it's not up to 10. All right, so we can take 7.5 as our A. Now let us discuss our n. What our n should be. So times 10 to the power of our n, remember that our n must be either positive or negative integer. So remember that when you shift your decimal point to the left, your n is positive. Remember when I said that? When your decimal point is shifted to the left, it is positive. When your decimal point is shifted to the right, your n is negative. So in this case now, we shifted this decimal point to the left, so it's going to be positive. Then how many times did we go from where the decimal point was originally to where it is now? 2 times. 1, 2. So that means we are going to have positive 2 as our n. Interesting, right? Yeah. So that means that we are going to have positive 2 as our n. Now the answer will be what? In standard form, this will be 7.5 times 10 to the power of 2. Very easy. Yes, but some students don't know it. Now, let's do another example. Let's do another example. Now, this says 9,000. 9,000. We are asked to put this in standard form. Remember that 9,000 is a whole number. And what does that mean? It means that each decimal point is at the end, even though you cannot see it. But any whole number has its decimal point at the end. All right? So that's where we have 9,000. This is where our decimal point is. And we want to put this in standard form. Okay? To put this in standard form, we shift our decimal point until we get to a number that is between 1 and 10. So let's go. If we shift, let me write this separately. Let me space it out a bit. All right. So this is where the decimal point is. If we shift this to the right or to the left once, we still have 900 here. And you can see that 900 is what? Is greater than 10. So we cannot use it as our A. Remember, we are looking for our A. And our A must be between 1 and 10. All right. So we change this to this point. Okay. We have, this is 900. 900 cannot serve as our A. So we need to shift the decimal point again. We have 90.00. This cannot serve as our A as well. Then we shift again. Now we have 9 points. You can see 9.000, which is same thing as 9. So you can see that this 9 qualifies as our A. All right, we can call this 9 our A. Yes, because it's between 1 and 10. I hope you guys are on board with me, right? Okay, so we can now write this to be 9 times 10 to the power of. Now remember that when you take your decimal point, when you shift your decimal point to the left, your n is what? Positive. Your n is positive. So what do you need to do? You count how many times you shifted your decimal point to get to your new destination. So if we count it now, we have 1, 2, 3. 3 times. And because we shifted our decimal point to the left, it's going to be positive 3. So this will be the answer. 9 times 10 to the power of 3. Now, another way you can testify that your n is positive or negative is when you see a whole number, your n should be positive. Whenever you have negative n, it's always a decimal. Is that clear? Whenever you have negative n, it's always a decimal. All right, guys. Hope you are doing great. If you have any question, you can ask me, because we are going to start from 0 to hero. Remember what I wrote on thumbnail, meaning that you need to grab this basic for you to be able to understand what we are going to do next, because we are going to go from this to a complex questions under this standard form. There are so many complex questions under standard form that so many of us cannot solve without the use of a calculator. So I want you to be sure that you are with us, that you're on the same page with us. Okay. Now, another example. If you have any question, let me know. Okay. Now, number 3. Another example. 5246. 5246. Now, for this, remember this is a whole number. This is still under whole number. We'll get to decimal. Okay, that is why you can see that their n is positive. All right. So 5246. Remember that your whole number, the decimal is at the end. All right. So we have 5246. So these are our decimal. So we move the first time 1. No. We still have 524. We move the second time 2. We still have 52.46. 52 is more than 10. So we go again. This time we have 5.2, which is perfect for our A. So we now write 5.2, but we are not going to ignore this because they are numbers. So we need to write them. All right. So we have 5.246. Now, how many times did we move our decimal point from its original position to its new position? We moved or shifted it 1, 2, 3, 3 times to the left, which will make our n to be plus 3. 3 times to the left, that will make our n to be plus 3, positive 3. So what you will now have is what? This raised to the power of what? 10 to the power of 3. Amazing, right? Okay. Now, the last but not the least. The last but not the least. What if you are asked to express this in standard form and you are told to solve this 73 times 89? 73 times 89. You are asked to leave your answer in standard form. What will you do? The first thing will be to multiply this out. Okay? So we say this multiplied by that. So we're going to do that quickly, and that will give you 6497. So we have 6497. But this is not in standard form. Remember, this is not in standard form. Now, how do we go? What do we do about it? Because this is not in standard form, we need to put it in standard form. So in standard form, it will be 6.497. I believe you understood what I did here now. I've been saying that. Let me write it here. So this implies that we'll have 6.497 times 10 to the power of, now, originally, our decimal point is at the end because this is a whole number, right? Now, if we take the decimal point 1, 2, 3, backwards 3 times, we are going to get to 6.97. So our 10 should be 10 to the power of 3. And it is positive 3 because we shifted our decimal point to the left. So when you do that, your answer or the value of your n is 3. Okay, so thank you, Donek. Thank you so much. I appreciate. So that is it, guys. Like I said, if you are joining us today, you are lucky because we are going to go from this basic to difficult questions on that standard form. And I also give you a math trick. Yes, there's a math trick on that standard form that will help you to say the answer or to put any number in each standard form in seconds without having to count or do whatever. All right. Okay. Now, can I ask you something? Can I ask you something? Now, this is what you need to do for me. Then change this to standard form. Let me give you classwork. I would like you to tell me what you think the answer is in the comments. Okay? If you want to take screenshots, I think this is the time for you to do that. That is if you are taking a note. So I'll give you 3 seconds to take your screenshot. 1, 2, 3. All right. So I believe that if you wanted to take your screenshot, you have done that. Now I'll give you classwork. The classwork says change this to standard form. Change this to standard form. We have 540000, number 1. Number 2, we have 3572 80. Put this in standard form. Number 3, 680. Just 3 of them. Just draw. It's very easy. Drop the answers on the comments and we move on to the next subtopic. I can see your solutions, so just drop the answer and we will move on. I'm still here, guys. Let me check something, please. Okay, I'm still waiting for your answers. Hello, Migo. So let me sit a bit, 5 minutes or 2 minutes, drop your answers. Then we go ahead and just drop your answer. For number 1, what is the solution? 540000 in standard form is what? I'm waiting, guys. What do you think the answer is? Donek, please send an email to me. Okay? Send an email to me. All right. No one has said anything. Okay. I want this video to be, I will post it as a replay. So I don't want a situation whereby someone will be watching it as a replay and it's somehow boring. Now, we are going to write the answer. Remember that this is a whole number, so the decimal point is here. Notice that we need to shift this decimal point till we get to this point. That is between the first two significant numbers. Yeah, that is what I wanted to tell you in terms of the matrix, but we get to that. So it's definitely going to be 5.4, right? 5.4 times 10 to the power of. Now we shifted our decimal point how many times? This is where the decimal point was, okay, before we started taking it to the other side. 1. So we have 1, 2, 3, 4, 5. So it's going to be positive 5. If this is what you got, then you are correct. Okay. Now for the second one, we have 3.5728. All right. Times 10 to the power of. Now the decimal point was here at the end because this is a whole number. Then we count 1, 2, 3, 4, 5. So positive 5 as well. Now the last but not the least, we have 680. So it's going to be 6.8 times 10 to the power of. The decimal point was here. So we count 1, 2. That is positive 2. Because we shifted the decimal point to the left twice. Okay. This one we shifted the decimal point to the left 5 times. And this we shifted the decimal point to the left 5 times as well. Okay. So if you are just joining and you seem not to understand what we are doing, you can watch this video as a replay later to show you how we started. All right, now what if you have decimals? What if you have decimal? Okay, just take your screenshot as well. For those that are taking their notes, take your screenshot in 3 seconds. 1, 2, and 3. Okay. Now let's change decimals to standard form. If you have decimals, so this one say expressing decimal numbers in standard form. In standard form. All right. So the first one says express 0.008 in decimal form. Express 0.008 in decimal form. Now, guys, this is it. Someone say, okay, trying to read some comments, sorry. Okay, now remember, always remember this rule, 8 times 10 to the power of n. Okay, and remember that your a must be between 1 and 10. 1 included, but 10 is not included, meaning that your a should be equal to 1, 2, 3 to 9. These are the values that your a can take up to. So I have 0.008. Now what is my a? My a from here can only be 8, right? It can be 8. So because I need to shift this decimal point, this is what I have. So to get to that 8 as my a, I need to shift this decimal point to get to 8. You can see that. So write 8 times 10 to the power of. Now, remember what I told you when we started. I said that if you shift, I don't know if you can hear me clearly because I don't want to shout. I'm having headache. So I said if you shift your decimal point to the right, your n will be, this n will be negative. But when you shift your decimal point to the left, your n will be positive. Now a decimal, this particular decimal, you can see where the decimal point is. And to get to our a, we shifted it to the right 3 times. So 1, 2, 3, meaning that our n will be -3 because we shifted to the right. Very interesting, right? Yeah. So that is it for this one. I would be glad if you can ask me questions, like anywhere you don't understand, ask me. I will gladly answer you. All right. Then number two, we have 0.00003. 0.00003. Now, the same thing. We need to shift this decimal point. We need to shift the decimal point to get to 3 so that we can use this as our A. All right. So we have 1, 2, 3, 4, 5. So to get to our A, we shifted this decimal point to the right 5 times. Okay. So we have this 3 can be our A times 10 to the power of -5. Now it is negative because we shifted this decimal point to the right 5 times. Hope that is clear. All right. Now, another example. Another example. So we have 0.0059613. 0.0059613. So we are asked to express this in standard form. So as usual, this is what we have. So we're going to shift this 1, 2, 3. I want to stop here because at this point, what I have now is 5.9. So this has qualified for our A. Remember that our A is between 1 and 9. Okay? It's either 1, 2, 3 to 9. So 5 point whatever is up to is can qualify for our A because 5.9613 is approximately 6. Okay, forget the long numbers there. Thank you, George. Forget the long numbers you're seeing. Okay, so we have shifted this decimal point 1, 2, 3. So this is where we are 5.9613. So 5.9613 times 10 to the power of, remember that we shifted to the right. So definitely our n will be negative. So how many times did we shift the decimal point to get to its new position? Now the decimal point was here and we shifted it 1, 2, 3, 3 times. So it should be -3 because we shifted to the right, it should be negative. All right, amazing. Now it's time for you to answer your own. For those of you that are there, I don't want you to just sit there taking down your notes without talking. Someone said something, he said, so you must put the decimal point between 5 and 9. Exactly, my dear. This is the reason, Amy. Remember that we said our A could be 1, 2, 3 to 9. Okay, now let me show you why it must be 5.9. If we should take this decimal point to this point, it will be 59.6. You can see that if we should leave here and put it the other side, it will be 59.6. And 59 cannot serve as our A. It cannot be our A because according to the rule, the A must be between 1 and 9. And you can see that 59 is more than the numbers that we're supposed to have as our A. You'll get it now, right? So that is why it must be at 5.9, because 5.9 is approximately 6, and 6 is still within the range that we can call our A. So that is why our A in this case is 5.9613 times 10 to the power of, then our n is minus 3. All right, any other question? Any other question? Before I give you people your own, no. Any other question before I give you your own too? Okay, now for those of you that are interested, kindly give me these numbers in their standard form. But before I do that, I will take a step backwards. Please take your screenshot for those that want to. Take your screenshot in 3 seconds, please. 1, 2, 3. All right. So I'm going to clean the board now, then drop classwork for you, which you will solve within 5 seconds or less. Because I don't want those that will be watching this as a replay to get bored. So that's why I don't want to give too much time between the questions. All right. So this says express this in standard form. Express this in standard form. Number 1, 0.00163. Number 2, 0. Sorry about that, guys. My phone fell down.